Yeah, welcome to my second lecture, and which is about the seismic data processing workflow and also using the software. So in the previous video, we have discussed about the seismic data acquisition, processing flows, and some of the example which was shown from the field data and how we do the processing on that data. So today what we are going to do is we are going to use the software for data processing, reflection data processing, and we'll show you some of the example and also doing the seismic data processing. So before we start the software, I would like to give you a small introduction how we use the software and what are the functions which can be used for processing. So we will be following one of the tutorial A, which is 2D processing, and the data name is 20 short line. So this tutorial A files are stored in the directory tutorial A under the processing software directory. So these are files stored in the directory. So we have the input dataset, which is called 20 CMP, which is compressed to the short line. So if we have .cmp file, so it means you have to uncompress the file to segway. But fortunately, I have provided you the segway file, so you don't need to uncompress the file. Just upload directly the segway file. And the second thing which we will be using for the processing workflow is at the flow, which is provided in the directory. A lot of workflows which we will be using. So mainly we will be using S20 velocity analysis workflow, and some of the workflow which we already been applied. So like S20 sequential flow, simple scaling for 3 input shortcut 107, 108, 113, which this one will be using. And also the brute stack with 2D reflection static will be applied for this using this workflow. So these are quite helpful workflows which you don't need to design by yourself. So this one is provided, so you can load this flow and give input data, then define your processes, and you can get the output of these flows. So there are 7 main sections which we will be doing in this lab. So the first thing is initialization of the project. So I will give you a small demo on that. Then we'll show you some of the command and flow window processing data, directory windows, header equations, and seismic window display, how we use the plot control and header view. And finally we will followed by the reflection static. So the first thing is how we start up the software. As mentioned in this slide, so we need to go to the processing software folder and we need to double click on the stubin. So over here you can go stubin. So you just have to click OK and close these tips. So now we need to see how we can define the new project or initialize the project. So over here you can go into the file. If you are doing a new project, see new project. So here is a tutorial project. So you have to make a folder like class test I have made. So let me rewrite this. So you can name the name test2. You can say save. Now you have to define the title of the project. The project title is processing lab. Then the project is 20 short line. Location is Malaysia. Country or you can define the name area offshore. So the date will be defined like this. So now you can choose project type. Is it a 2D survey or 3D survey, and what type of unit you want to use or used in the process in the acquisition. So now we're using 2D survey and the unit will be in meter. Say OK. So over here, as I mentioned, initially you need to do the demultiplexing, but if you don't have that, so you have to click on this and you can add your seismic data. Once you click and hold, so this is the sign for add segway data. So you can go. So the data is in tutorial A 20 short line. So here it will show you how you can, what are the things you can see from the data. So the start time of the data is 0 and number of sample is 1000, sampling rate is 2 millisecond, and total traces are 2400. So these are the real header. You want to see EB, ASCII, EBC, DIC, or you can see in the binary header, trace header, data info, and histogram. So once you have loaded the data, you have to hit OK. So it will show you trace sequential number. This is the name of the headers. What is the minimum and maximum value? So if we talk about the trace sequential number, its minimum value is 1 and 2400 is the number of total traces. So you can close this window. Now if you want to see your data, you can click here and the data will be displayed on your screen. So this is about initialization of the project. So the second thing we already done is initialization of the project. We have load 20 short CMP. We didn't go for uncompressed file, but we go directly. So now I will show you some of the flow and command window. So you can get this flow and command window from the job flow, Vista and command windows. Here I will show you some of the window, job and flow window. So we have input data, output data, create data, geometry, trace edit, scaling, filtering, and so on. So mainly we will be using our input output exactly what we have to use. Then the second thing what we will be using is let me close this one. So here you can see clearly you have scaling, filtering, resample, deconvolution. So these are the job flow which we can insert into design our workflow. We have stack, many commands, we have it here. And the third thing is the dictionary window, input transfer formula. So normally the standard supplied Vista Direct dictionary will correctly handle 99% of all data. So normally in the Vista dictionary, what we do is, in Vista Direct dictionary we can change any type of header format from another header format data. So I will show you one example here. So this is a part where you can choose the dictionary, desired dictionary. So here we have used the standard dictionary. So second thing is we can select the item vista header by clicking in this area, and select the item by clicking this area. Also you can click this area. Create equation from here, I will show you in the software as well. Then select data type, which type of data you want to use. If you want to change integer data, or and also you can change the byte location from one location to another byte location. I will show you in the software as well. Let me close this file. Dictionary, add a dictionary, input transfer. So as I mentioned that you can change what type of dictionary you want to use. So we will be using standard Segway dictionary. There is a Segway, header, Seismic, IBM. So many type of dictionary we have: Segway, header, Seismic, IBM. So but here we'll be using standard Segway dictionary. As I mentioned that you can choose this panel. So either you want to choose long integer, short, floating point, or anything you can choose here. And location byte, so you can change the location of byte from 21 to 121, and byte size you can change from 2 to 4, 4 to 2, any other location you can change. And another interesting thing is, I will show you here. So header equation, you can define the header equation. So when you click in the small checkbox just to the right dictionary name, you will be allowed to enter a definition mapping for this item by defining it as a combination of other headers, items, and arithmetical constant. So I will show you. The step one is you have to click onto this box. So here you have already one of the equation, multiply constant by 0.1. But in this, like with the trace sequential number, we don't have any header equation. So here you can choose the constant. You want to add the constant, multiply the constant, or whatever you want to do. So let's say we can add 10, add constant, or subtract, either you want to choose. So we want to add, increment, no increment. So you say OK. So then you hit OK. So your trace sequential will have add constant and each traces. So now your first trace will become 10 trace, 10 will become 20, or 100 will become 110. So this is a flow which I have shown you already. So in this case we can put multiply to the trace sequence number. So the fifth tool of very interesting tool is a plot command. Now this is really very interesting feature which is used for controlling your seismic data. So this can be opened in a variety of ways. Right click from the input icon and flow window, choose the window display, in pull down list and interactive, the top menu. I will show you in the software as well. So over here you can see we can close this. No. So let me close this one, discard, because we don't want to save it. So here you can go and press this button which is a seismic display. So here the short order data will be shown here. So the first is a seismic data plot parameter, which we'll be discussing in. So here you can see a lot of options. So the first one is a view, number of view, one horizontal view, vertical view, any type of view. And the second is option. In this we can change the display, like you want to change the variable density, so you can change the display, but for now we will be using variable area. It's not suitable. Bigger plus variable area, so this one looks quite okay. So the third parameter, annotation parameter. In this you can change, and you can see how many header information you want to see in a display. So here we are showing the short point number and channel number. So you want to do up, down, you can change. Now the channel number will show on the top and short number at the bottom. So it's not a big deal. If you want to add, you can add, let's say, CMP number. So now you apply, CMP number will be visible here. In display option you can see how many parts you want to see, how many traces you want to see in a window, vertical, horizontal, and offset as well. So short display, you can see the processes, scaling, coloring, dead trace overlay, and timing lines. So these are the timing lines you want to change. You can change any color, up to you. Let's see, the line will be changed. Let's say you want to do the red. This can be changed anyway. So the second is, if you want to add a note, let's say you can say this before, so this add note will be going on with you anywhere you want to see, and you want to delete note, you can delete as well. So this is a color display or the scale, color bar scale. So here it will show the red is your positive and blue is negative amplitude. If you want to zoom in, you can select that here. So the blue one we haven't filled it, so we can fill it. Just double click to resume it, so we can close this display. In the view option you can see refresh color, current screen display, full zoom, you can capture, you can print, either any part you can do it. Okay, let's move to the annotation parameter. Display is done. So now we use the interactive tool, which is very essential for seismic data processing, which is trace scale, reverse polarity, muting from top, bottom, or surgical muting, and first break picking, and the time gate. So usually the trace scale command is used to remove the trace which is affected by the noise or not a desired trace in the data. Okay, I will show you in the software how we do that. So this is your trace scale icon. You will go into the click trace scale. Now you pick the data for trace scale. This whole window you can kill. Let me zoom it in. If you want to kill this one, 3, 4. On this display, like this one, you think this trace is not okay. You need to zoom it in. Okay, you have killed the trace. If you think this is not, you can kill the trace. So now you see this one is already removed. The very good example is here. So this trace is not desired, you can kill this trace. So the second thing is the reverse polarity. And normally in the seismic reflection, we have the reverse polarity for DHI, but in processing, what we are doing, we are dealing with the reverse polarity. Normally it is very bad when we have, like I show you one example. If we have this reverse polarity, let's say this is a positive and here is a negative polarity. So in that case, once we stack the data, it will become zero. So we will have no amplitude. So that's why we use reverse polarity to kill the reverse polarity. So like pick the trace with reverse polarity. Let me see if there is some good example. Yeah, this one. So let me zoom it in first. This one. So we can change the polarity to the right. So in this case, this will become the positive amplitude. It will not affect by any other data. Okay, so the sixth thing is a very important thing, which is mute. So this mute command is used to kill either top, bottom or surgical trace mute. In case of linear noise, which is consistent and visible in the short gathered data, we can use this operator. And also in case of single trace killing, this is very essential. So let's move to the software. I will show you how we kill the trace. So let's close this one. So this is a mute button. Now first I will show you the bottom mute. Let's say we move here. So let's say we are not required this data below this reflection. So this data will be removed or mute. Then in case of some area where we have noise because of the streamer here, or such as this one, this trace, so we can mute the top one here. But in this case I will take one of the first break or first arrival. So the first arrival is removed and you see the trace was here also removed. And another thing is the surgical mute, which is very important. Let me apply on a new data. So this one we don't want to save. So now we go to the mute in the surgical mute. So as I mentioned, this this is a ground roll. So by using the surgical, we can remove this ground roll noise. So you see, quite good. So now we do the stacking, it will be perfect. And also if we want to do a single trace surgical mute, we can also choose this one. You see this one trace is removed, but in this trace only this part is removed, but this part has left behind. So this is called a surgical single trace mute. So here is an example of top surgical trace mute, and this is a very good example. Over here we can use all of this muting from top, let's say bottom surgical, as well single trace surgical mute. So now we will move into the first break picking, which is very essential in seismology. The first break picking is the detecting or picking the onset arrival of reflected signal from all the signal received by the source array and produced by a particular source signal generation. And it is also called first arrival picking or first break detection. Okay, we'll move to the first break picking first. So here we will go, we'll close it and open a new data set. So this is the icon for first break picking. So once we have activated, so here you can go manual first break picking. So you see this black dot is the first break, first arrival in the data. You can close it and then go to the next shot from here. So you can see the black dot can be picked as first arrival. Then for the third shot, gather data. So here is another option. So now we was using manual first break picking. The second is manual first break pick with the pilot trace, and the third thing is auto pick current record or auto pick for all the record. So for the sake of understanding, and we can use auto pick all record, but there is some problem. Let me reopen it. First break picking. So normally the manual auto pick will be working, but there is some error. So now we can do the manual break picking by the pilot plot. So here you can see, you just have to click on the top, it will be picking automatically, or you can choose auto pick, manual pick. So here you can see these are the first break will be picked by manually. So here and so on. And also from this option you can choose either you want to use you want to pick the peak, trough, or up to 0 or up to down to 0. So it's mean right now we are picking the peak of amplitude. So after this you can use this button to plot XT view first break pick. So currently we have picked only the 2 short gather data, so that's why this is showing like this, but in actual it will be looking like this. So over here, let's say you have some problem here, so this one is not picked well, so then you can go back and repick the first break. And the another thing is time gate. Time gate is a function which works for the creation a certain range of time window to apply any deconvolution operator such as signal to noise ratio. So I will show you an example here. And if you want to save any task before going, you can go and hit the save first break pick or any type of. Once you go to the save, you can use this file as a first break picking file. So there is a lot of files, each step of the project you can save, but right now in this lecture I'm not saving anything. So now we can close this one and reopen the data. So I have to show you the time gate. How does it work? So this is a time gate. Let's say we want to, so we have to option time gate, what type of gate color we want to use on the top, bottom, definition, short point and short line number. So here you can choose the top. So let's say I want to use only this part. Double click and to remove, and this is the bottom I want to choose. Then you can this delete time gate and save time gate file. So this part will be saved separately and you can use any type of operator here in this part. So these are the seismic header view which can be plotted against any type. Let me show you seismic header. So close this one and reopen the seismic data again. And then here you can right click. So here we are talking about view edit seismic header. So we can right click on the data and click on the view edit seismic header. So now you have the trace number, then trace sequential number is the same. Then you can add channel number, CMP, number, and offset. So now you can plot two of the parameter like this. And this separately. So here you can see CMP number from 0 to 50, 100, how it is being changed. and offset also you can see from 0 to 1000, then it's extending from -500 to 1500, and the loss offset is the maximum offset. This is a good option to see the visualize your data. So like Seismic window display, this window can be opened from variety of window in Vista. It performs many useful functions with header value. The column of header values may be moved, delete and change in the size as well as shown. So now the first introduction of the software has been done, and I've shown you how we can pick the first break and first refraction static. So now the first experiment which will be done is the reflection static. So this lab work will be given to you for doing the reflection static of the data. So these are the procedure which is mentioned here. Now you have to pick the first break for short 20 raw data set, and use reflection static window, activate from interactive reflection static as I mentioned. And now in this case you have to process all this data, and you have to save the static value to the Vista header world, and then add static sh command to flowchart for the brute stack and recompute the brute stack with the static after NM operation. Note, make sure you pick the same static header words that you originally saved the static to compute the result with and without static.